Distilling is often an industry with a big environmental impact, using high rates of both water and energy to create products. It doesn't have to be that way though, and that is the principle upon which Marble Distilling Company in Carbondale, Colorado was founded. My name is Grant Stump, and I served as a Sustainability Fellow for Marble Distilling. Today, we will talk about Marble's business model, the challenges they face, and some potential solutions to continue their industry-leading environmental efforts. Founded in 2015 by CEO and head distiller Connie Baker, Marble Distilling's business consists of a distillery, a luxury inn, and a tasting room all on one site. Located in the Roaring Fork Valley of the Colorado Rocky Mountains, Marble has placed sustainability at the heart of its business model. At the center of those efforts is the Water and Energy Thermal System, called WETS for short. WETS works to save both water and natural gas by harvesting the heat from distillery processes and using that energy in other parts of the facility. This system also results in zero process water being sent to the sewers, something that can't be said for many other distilleries. Marble's other sustainability efforts include a 35 kilowatt hour solar array on the roof, local partnerships to ensure that stillage is used by local ranchers for feed and compost, as well as sourcing glass from US-based companies with strong sustainability practices. As was mentioned before, distilling is a resource-intensive industry, where water is often used to remove excess heat energy from the distilling processes. This water is then often sent straight to the sewers, wasting both the heat energy contained in it and the water carrying it. Marble Distilling knew this was not going to be an option in their mountain ecosystem. Thus, the WETS system was born. WETS uses two 5,000-gallon tanks, a hot tank and a cold tank, to harvest heat from the distilling processes. This energy is then concentrated using a series of heat pumps and can be used to accomplish tasks around the building, such as heating rooms, preheating domestic hot water, or melting snow on pathways and sidewalks around the building. Even with the water usage from both the inn and the tasting room included, this system leads Marble to have a water usage rate that is 15% better than industry average. As with any innovative system, WETS does have some challenges that need to be addressed. The primary challenge for WETS, and the one that I spent my fellowship focusing on, is excess heat in the system during the summer months. In order to function correctly, WETS must be able to expel the excess energy it collects, either into processes within the facility or through natural energy loss to the environment. In colder months, this is not an issue, as for every degree Fahrenheit drop in temperature outside, the WETS system loses about 7 kilowatt hours of energy. However, in the summer, heat is not lost from the system nearly as much and builds up. This excess heat threatens the compressors on the heat pumps. In order to protect the heat pumps, the hot and cold tank must be mixed and brought to the same temperature, which tends to be around 95 degrees Fahrenheit after the mixing. While this does allow the distillery to continue saving water, it does cause the system to lose its ability to preheat distillery processes and domestic hot water efficiently. This in turn requires the distillery to burn 4% more natural gas each year just to bring those processes up to functional temperatures. That contributes about 3 metric tons of CO2 equivalent to the atmosphere. In order to address this excess heat challenge, I have 2 recommendations. The first is to reconfigure the system so that the hot tank can be cooled by the dry cooler. The dry cooler provides excess heat dissipation, but is currently only configured to cool the cold tank. By connecting the hot tank to the dry cooler, there will be a greater difference in temperature, therefore allowing more heat to escape from the system. This reconfiguration will require a significant upfront investment, but that can be paid back in a very short period due to the ability to increase production capacity in the summer. Additionally, should this reconfiguration resolve the heat issue completely, it will allow the distillery to reduce their natural gas emissions by 4%, saving both money and environmental impact. There is a possibility that the first recommendation will not fully achieve the cooling that is necessary to resolve the issue, especially as production in the distillery increases. In that scenario, I recommend that Marble Distilling install evaporative cooling media on their dry cooler, further increasing the ability of the system to lose heat in the summer months. Due to some of the rebates available, this investment would still pay off in about 1 year and would achieve the same environmental and production benefits as the first recommendation. The downside to this recommendation is that it would increase annual water usage by 7% due to evaporation within the cooling media. While this is not ideal, marble distilling would remain below industry average even with this increase. The current status of this project is that bids have been received for each recommendation, and the timeline and scope are currently being determined by the distillery. In addition to the excess summer heat issue, my fellowship did cover several other sustainability-related projects, including process recommendations, the groundwork for a comprehensive waste study, recommendations on how to more efficiently use the building controls database, as well as the creation of Marble Distilling's first ever sustainability report to be published in late 2021. It has been an honor to work with a company that is wholeheartedly devoted to creating high-quality drinks and experiences while operating sustainably. Marble Distilling truly is a leader and innovator in the sustainable distilling space, and they are willing to walk the talk and bring others along with them. Thank you so much for watching, and remember, drink sustainably.